Welcome everyone. Today we're going to explore a topic that has become critical: the ethics of algorithms and the importance of ensuring they operate fairly and transparently. Algorithms drive decision-making processes that hold a tremendous amount of power. Decisions about loans, diagnosis, peril, hiring, and even criminal justice can now be made by a piece of software. But with this power comes significant responsibility, and that's where concerns about fairness, transparency, and accountability come into play. So what do we do about it? The answer lies in algorithmic auditing. Think of it as a system of checks and balances designed to ensure that algorithms operate ethically and fairly. We can break this down into four key areas. First, we have data integrity checks. If the data used to train algorithms is biased, inaccurate, or unrepresentative, then the algorithm's decisions will reflect that. Data integrity checks ensure that the data is clean, unbiased, and represents the population it is intended to serve. Second, we look at auditing the definitions of success. What does the algorithm define as a successful outcome? Is that definition aligned with ethical standards? For instance, if an algorithm used in hiring favors certain demographic groups over others, it's failing to meet fairness standards. Auditing helps evaluate if these definitions are fair. Finally, we focus on accuracy and error rates. That also includes auditing for performance disparities, a key practice in ensuring that algorithms are fair across different demographic groups. Even if an algorithm is 99% accurate, that 1% can represent a significant number of people being treated unfairly. We need to assess these discrepancies, identify patterns of bias, and make corrections. Let's explore each item individually. Now, let's dive deeper into data integrity and its role in algorithmic systems. Data integrity refers to the accuracy, consistency, and reliability of data throughout its life cycle. This is crucial because algorithms learn patterns and make decisions based on the input data. If that data is biased or incomplete, the algorithm's outputs will mirror those flaws. In some cases, this can lead to unfair or harmful consequences. For example, if an algorithm used in hiring decisions is trained on biased data, it may unfairly disadvantage certain groups of people. Let's explore some of the key sources of data bias. The first is historical bias. This occurs when the data used to train algorithms reflects past prejudices or discrimination. Think about datasets from sectors like housing or employment that have historically marginalized certain groups. Algorithms trained on such data can perpetuate or even amplify these inequalities. Next is sampling bias. This happens when certain groups are either underrepresented or overrepresented in a data set. This imbalance affects how the algorithm learns, skewing its outcomes toward those overrepresented groups. Imagine a healthcare algorithm that is trained primarily on data from one demographic. It will be less effective or even harmful when applied to other groups. Then we have measurement bias. This arises from inaccurate or inconsistent methods of data collection. If the way data is gathered is flawed, it introduces errors that affect the algorithm's predictions. Now, how do we prevent these biases from affecting our algorithms? This brings us to auditing data integrity checks. The first step in the audit is data validation. Here, we verify that the data is accurate and free from errors by checking for inconsistencies, anomalies, and missing values. It's like a quality control step, ensuring that no red flags are missed. Next, we conduct bias detection, where analysts closely examine the data to find any patterns of underrepresentation or overrepresentation. This helps in quantifying the biases that might skew the algorithm's performance. Once these issues are identified, we move on to data cleaning. This involves correcting inaccurate records, eliminating duplicates, and fixing inconsistencies. It's a crucial process to ensure that only high-quality data informs the algorithm's decisions. Lastly, there's the essential step of maintaining thorough documentation. This involves keeping detailed records of where the data came from, how it was collected, and the steps taken during the auditing process. Researchers proposed a concept called data sheets for data sets, which advocates for standardized documentation practices. This not only promotes transparency, but also ensures accountability in the development of algorithmic systems. Each of these steps, validation, bias detection, cleaning, and documentation, contributes to transparent and fair algorithmic systems. By ensuring the integrity of our data, we can build systems that are both accurate and equitable. Thank you for your attention. I hope this lecture was insightful for you. You can find the academic resources that provide in-depth analysis for these matters at the end of this video.